the happiness. Admissions open. SRM Ishwari Engineering College.
Good evening to all. Sir, shall we start? HOD sir.
HOD sir. Shall we start, sir?
Are you asking me?
No, sir, we are actually waiting for our HOD to respond.
Sir is there, ma'am, inside. HOD, sir, shall we start, sir?
So I think sir is muted. Just give him a call, sir.
Yes, ma'am. Yes, ma'am, I'll call, ma'am. HOD, sir, shall we start, sir?
Sir, Marish, sir.
Yes, sir. Yes, sir. Shall we start, sir?
Am I audible?
Yes, sir. Now it is audible, sir.
1 second. Hello.
Now it's audible, sir. Yes, sir.
I am
Audible, sir.
Shall we start, sir? Sir, shall we start, sir? HOD, sir?
sir. Yes. Kekda.
Yes, sir. Kegel, sir. Kegel, sir. It's audible. Shall we start, sir?
Yes, sir. We can start.
Okay.
Good evening to all. A warm welcome to all the learned faculty members from Department of Electrical Electronics Engineering, Ishwari Engineering College. Today we have convened here for the 6th day of International Faculty Development Program on Research Innovations and Emerging Advances in Electrical Engineering. And today we are going to have a session on renewable hydrogen energy systems for islanded microgrid by Dr. Alamgir Hussain, Postdoctoral Research Fellow, Queensland Micro and Nanotechnology Centre, Griffith University, Australia. Now, I would like to invite our respected HOD, sir, Dr. E. Kaliappan, to give us a welcome note.
Thank you, madam. Very good evening and warm welcome to all the members who have joined with us for this International Faculty Development Program on Research Innovations, Emerging Advances in Electrical Engineering. On the 6th day, that is the last day of this 1-week faculty development program. So my best wishes to all the participants who have joined with us, who have shown interest and in attending this program continuously. I take immense pleasure in welcoming the speaker of today's session, Dr. Mohammad Alamgir Hussain, postdoctorate research fellow, Queensland Micro and Nanotechnology Center, Griffith University, Northern Australia. Sir, welcome, sir. Welcome you, sir.
Thank you. Thank you.
It is our pleasure to invite you to join with us for this International Faculty Development Program. And thank you so much for accepting our invitation to join with us. And
It's
I
my
would like to
pleasure.
extend my best wishes to the coordinator. Thank you, sir. My best wishes to the coordinators, all the 4 coordinators who have shown a lot of interest in arranging this program, tremendous work they have done in coordinating with all the members who have participated with us on all these occasions, and also having a YouTube live. Best wishes to you once again. And this is the last day of this 1 week faculty development program. Hope you would have enjoyed all the sessions, and please continue your support. And as in the first meeting I mentioned, we can also do some collaborative research works. We have a lot of laboratories in the college, in the department. We have a specific high voltage transformer testing facility. We have renewable laboratory. So we can collaborate in lot of research activities. So at this moment, I would like to welcome you all for that collaborative research. So with these few words, I would like to once again welcome all the participants, the speaker, and all the other members who have joined here for this session. Thank you so much. Thank you.
Thank you, sir. Thank you for a warm welcome. Now, I would like to invite Mrs. J. Lydia, Assistant Professor, Tripoli Department, to introduce our speaker of this session.
Thank you, Madam. Good evening to everybody present here. I would now like to introduce the speaker for the session. Dr. M.D. Alamgir Hussain received BSc Engineering in Electrical and Electronics Engineering with first class honors from the Dhaka University of Engineering and Technology, Bangladesh in 2012. He also completed Master of Engineering and PhD programs from the University of New South Wales, Australia in 2016 and 19 respectively. He was awarded several prestigious scholarships, including UNSW Canberra Study Canberra Scholarship. He received the Best Research Presenter and Second Best Presenter at UNSW Canberra Research Day in 2015 and 17 respectively. Top Peer Reviewer 2019, Outstanding Reviewer from IJEPES in 2017, Prime Minister and President Gold Medals. He had published more than 20 international journal papers and 15 international conference papers in his specialist field. His field of interest includes control, optimization, and prediction of renewable energy sources. He is currently working as a postdoctorate research fellow at Griffith University, Australia since March 2021. Before joining in the position, he worked as a postdoctorate research associate at the University of New South Wales, Australia for around 1.5 years. Currently, he is developing a hydrogen DC microgrid lab at Griffith University for commercialized purpose. A very warm welcome to you, sir.
Thank you very much.
Now, we would like to hand over our session to the speaker.
Should I start my presentation?
Yes, sir. You can start.
Okay. All right. Can you see my presentation slide?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you for your invitation to give me a chance to talk about some of the project about a renewable hydrogen energy system for an islanded microgrid. As a research fellow, I am also exploring the hydrogen energy system. So I thought that it is better to share with the new researchers so that we all can explore together. So as this faculty development has a lot of researchers, those whose background are different. So I will basically present from the very basic principles so that everyone have understanding of what is needed, what's the advantage, the disadvantage, and finally I will go with some of the project with some of the link. I hope you will enjoy my presentation. So in this talk, I will go through some of the introductory talk, then renewable energy in respective of how renewable energy can mitigate the problem, and as renewable energy has some shortcomings, so hydrogen energy came into the play. So I will talk about the hydrogen energy and how this hydrogen energy can be used for producing electricity. So it means that using the fuel cell. So I will go through the fuel cell, and then I will come with the solar and hydrogen power generation and the future work and the conclusion. So humanity is facing an uphill battle when it comes to preserving our planet in order to avert some of the worst effect of climate change. Experts say that we need to stop global temperature from rising 1.5 degrees Celsius above pre-industrial level. To do this, global carbon emission need to drop zero by 2050. In addition, it has been estimated that 1.2 billion people globally will be without electricity access by 2025. 1 million people are connected to unstable network and are regularly exposed to power outages. It may thus be considered that 2.2 billion people, that is around 35% of the global population, are under-electrified, with a massive use of diesel generation. Indeed, with an installation of diesel production capacity of 600 gigawatt, for which it has been estimated that half is installed on off-grid sites, the need to reduce dependency on fossil fuel and CO2 emission is mandatory. As a result, renewable energy sources are being used to generate power. Now the question is, how much renewable energy can reduce? Can the CO2 emission be reduced 100%? Okay, now let's explore that actually from where the carbon dioxide are emitted. Although the statistic has taken from 2014, but the pattern or percentage is almost same. So if you now explore, we can see that electricity and heat is responsible for around 60% to produce the greenhouse gas. Whereas transportation is the second, is 22%. Industry is 9%. Residential is 2%, and other are 8%. So majority of the CO2 emission is coming from electricity and heat. It means the power generation sector. So if we take care of the power generation sector, so majority portion of the carbon dioxide emission can be solved. But what of the effect? Can we replace the whole electricity connection with the renewable energy? Okay, let's explore. Actually, what we mean by renewable energy, that is not only about the solar and wind, but we often pronounce the solar and wind. Whenever we say renewable, it's it's a remind us talk about the solar and wind, but no, there are other types of energy sources. Those are also renewable. For example, hydropower, marine energy, geothermal energy, and bioenergy. So why we talk about solar and wind always? What's the problem with the other generation? Where we can see that the greater than 50% of the renewable energy is coming from hydropower, but we don't generally talk about renewable energy means hydropower. Why? Because hydropower can be found from a very specific region. It's not abundant. We cannot find. We cannot build the hydropower in every places. It has some constraint that need to be fulfilled. So it means that the expansible is not expansible. It's not flexible. It will not expand as the solar and wind can. So hydropower, although it is majority portion and it's very stable power system, it's reliable power generation like the conventional power system, fossil fuel. But the hydrogen power has some limitation. So in this case, in the majority case, we cannot consider the hydropower for expansible purpose. The other geothermal, biogas, marine energy, they have also limitation. It's not abundant. But in terms of solar and wind power generation, it's abundant, we know. And in 2018, the global renewable energy capacity is to 2,351 gigawatt, which is around 27.1% of the total power generation, of which solar capacity was 486 gigawatt and the wind capacity was 564 gigawatt. So solar and wind is expanding. And if we see our graph, we can see the solar and wind is continuously increasing. So now the question again, can the 100% renewable energy reduce CO2 emission zero? Of course not. Of course not. Because we mentioned here that is around 60% responsible. What about transportation? Can we replace with the renewable power generation all the transport? No. But we can use an alternative form, for example, electric vehicle, but this is not the renewable energy, but it's CO2 emission. It can keep the CO2 emission zero. Of course, so there is a role in transportation sector, but it's not about the renewable energy. Some of the industry, that's a mandatory to use the diesel generator or other generator. So where or other form of a stable power generation is needed, but renewable energy, as you know, there are some issues. So we cannot totally replace the industry sector, residential, the cooking system, or other factor. We cannot fully replace with the renewable energy sector. So renewable energy sector basically can meet around maximum 60% of CO2 emission. It can reduce to zero, but not the 100%. And the main reason of renewable and solar power is increasing because these are the least expensive power generation source as compared to the conventional power generation system. Even solar wind with the storage system is cheaper than the peaker plant. Peaker plant means the plant which is operated during the peak hour only on demand. So in this case, still solar or wind with the storage system is cheaper than the peaker plants. Generally, peaker plant is gas plant we use. So in South Australia, they replace with the wind and storage system. Instead of using the conventional power generation, they use wind and storage, and they're making profit. So what is the actual issue with the renewable energy sources? If we consider that, okay, now we are taking responsibility for 60% of reduction of CO2 emission. So if we do this one with the renewable energy, but the renewable energy has a lot of issues. So what are the issue? As you know that because of the renewable energy system into the grid or off grid, there is an issue with intermittent power supply. Power is not always available. Power quality issue, low inertia. solar and wind has a inertia issue, and it's also has a power sharing issue because this is not the dispatchable power generation. So it has a power sharing issue, and as well as the energy management, including prediction. So if we look at the power generation curve of the renewable energy system, then this is the PV panel curve, and it's California, and it's called, and there is a dark curve. It's look like dark, and this curve is created because of penetration of solar power generation. Because in the morning, when sun rises, renewable generation, especially solar power generation, start increasing. So if solar power generation start increasing, at the time the demand of the network is reducing because everyone is using their own solar power. So renewable energy is producing where the power demand of the network is reducing on the daytime. Then when the sun is again is in the afternoon session, the power generation from solar is reducing, and then the power demand in the network is increasing. So this dark curve, if we see here, we can closely look that in 2012 it was almost flat, but with the time, with the integration of solar energy system into the grid network, the demand of the network is decreasing. It means that it's decreasing. So, and this is megawatt range. It means that there's a huge gap in the noon. At the noon to 12 p.m. there is a huge gap, and if we consider here at 6 p.m. so this amount of power need to supply. So it's this causing a issue that they're making rules to integrate further with renewable energy system, because this amount of power generation from where they will supply, and if there are 1 or 2 days of rainy or other, so this amount of power need to maintain the reliable and secure power supply, but it's very difficult. So because of the renewable energy, especially PV integration, this is happening. So this is the new challenge. There's a huge ramp. So how we can mitigate this one without using the diesel generator? Similarly, this is the wind power generation curve of a wind farm in Australia. And we can see that the power is fluctuating. It's not a stable power, but we can make this power stable. We can use the energy storage system. If we use an energy storage system and if we capture this energy, then we can ship to here. If we capture this energy, we can shift here. This energy we can capture and we can use the later. So it means that if we use energy storage system, it's not about only battery, but other form of energy storage system. For example, pump hydro system. But pump hydro system has an issue. For example, it's also related with the geographical area, and not every place is suitable for pump hydro storage system. So in pump hydro, how it happened that if there is excess power, they pump the water into a certain level, and during the off-peak hour, they release the water. So turbine move and power is generated. But this storage system is not viable for every place. It needs certain specific geographical area for this one. And the storage system is a good solution, but we need to think about energy storage system. It's good for short-term energy storage system, but for the long term, for example, if we want to change the pattern in the summer, the energy production of summer to the winter, so this large amount of energy storage is quite expensive, will be for the battery integration. And conventionally, if we consider a islanded microgrid where there is no grid connection, so what will happen? So in this case, there is an issue for renewable energy that it cannot control the voltage and frequency. So either conventional generation system, for example, diesel, is needed or a large scale battery storage is needed. But large scale battery is expensive. It's expensive, it's take space. So another way is that if you use the diesel generator, so what will happen? The excess energy will be wasted. If you use the large scale energy storage system, it will be okay, but it's expensive. It will be expensive, it will take large place, and it has also environmental issue. So actually, if we use a conventional generator, so what is the problem? Diesel. So it emits the carbon dioxide. So our goal was zero emission by 2050, but it's producing the CO2. So it's not environmental friendly. The fossil fuel is limited source. When it operated, it creates noise, and it has low efficiency, around 20 to 25% efficiency. A power generation cost is high, and there's a water pollution. So if we use the energy storage system, what are the problem? It's difficult to dispose of in a safe manner. It's low energy density. It means that it requires a lot of places, as I mentioned before. It has long-term storage issue because we cannot store it for a season, 2 or 3 months. It's for large scale, it's expensive. There is a environmental concern. It needs large use of land, and it's need to frequently replace. Okay, so which are the technology that can solve this problem? So researcher is now start thinking about the hydrogen energy. So hydrogen energy is not found basically freely in nature. It only exists combined with other elements, for example, water, in a combination of 2 hydrogen atoms and 1 oxygen atom. So to get hydrogen, you must produce it by extracting it from naturally occurring compound like water. And the feature is that if you, for example, if you want to ignite, this is hydrogen is a gas, we know. So it's carried the chemical energy. So if you ignite the CO2, if you ignite the hydrogen gas, what will happen? It will ignite with the oxygen in the air, and then there will be some leftover water, and it will produce heat. So actually, if we compare, this is a gas, and there is another gasoline. This is also gas. So why people want to use the hydrogen? Because if you look at the 2 car, it was in a simulation mode, and this is hydrogen gas. It was a leak, and it was a fire. So hydrogen is going upward, whereas the other gas is spreading around the ground. So its cause is more dangerous, but in hydrogen, it's just go straight. It doesn't flow around, so it means that it's much safer than this one. If the car is flipped, still it will go upward, not like that. So that's why the researcher is want to use the hydrogen. This is one of the safe gas, we can say, and there are a lot of research is going on the hydrogen gas. Okay, so what are the merit and demerit of hydrogen? And the hydrogen, it can store as a compressed gas or in a metal hydrate with a high energy density. It means less space is needed as compared to the battery. The energy can be stored and reconvert hydrogen into the electricity with the help of fuel cell technology. It's a reliable and clean power supply all the time. It enables wind and solar power generation to act as a standalone primary supply. The current wind and solar is not it cannot be used as a standalone primary supply, but if we use the hydrogen, it can be considered as a standalone primary supply. The energy supply is independent. Therefore, it is useful for island and microgrid where there is no need for diesel generation. So The energy, hydrogen energy, can be stored for the long period of time, and this because of the hydrogen, it can replace basically our gas and diesel generator with sustainable solution. It's emission free, 100% clean, and the PV array, we can operate it in a maximum power point always. We don't need to curtail the PV power. We can produce the hydrogen from the extra PV power. So it means that we can always operate the PV panel with the maximum power point and no limit on production and storage. But of course, everything has some drawback. Producing hydrogen is now expensive, and there is a lack of infrastructure to transport and store, and fossil fuel are also expensive. So the common two method to produce the hydrogen is steam methanol reforming, which is generally used in commercial purpose, and it's used the methanol gas from where the hydrogen is produced. To produce it, it needs high temperature steam under the 3 to 25 bar pressure, and it reacts with the methanol in the presence of catalyst to produce hydrogen, carbon monoxide, and a relatively small amount of carbon dioxide. So of course, this, whenever there is a carbon dioxide or other gas is producing, of course, this will not consider as a green hydrogen. But there are other methods to produce hydrogen using microbes that use the light to make the hydrogen, converting biomass into gas or liquid and separating the hydrogen. Another is the solar energy technology to split hydrogen from water molecules. This is known as also electrolysis or green hydrogen. So if we consider, actually there are a lot of other methods to produce the hydrogen, but these are the hydrogen production strategy that where steam reforming is responsible around 38%. So majority of the hydrogen is produced by reforming, and others coal gasification and the electrolysis use 24%. Electrolysis means that it split the water and it produces hydrogen and oxygen, and there are other methods that also produce the hydrogen. So for the green hydrogen, we need to use the electrolysis process, where there's a water, an anode and cathode should be, and we need to supply the electricity. If this electricity is come from the renewable energy sources, it means that this is green hydrogen. It has no detrimental pollution or effect. But if we use this electricity, if come from the other sources except renewable energy sources, of course there should be some pollution issue or other gas will be emitted from the system. So that's not like green hydrogen. But if we use the renewable energy sources, it's a green hydrogen. And we are all familiar with the electrolysis process where anode and cathode, and if we connect with the battery system, so it means that it will produce hydrogen and oxygen, and the from the water, and the hydrogen gas will be around 2 times more than the oxygen, because as you know, the H2O, so it means that hydrogen gas will be 2 times higher than the oxygen. So this is the process, this is the electrolysis process from where we can get the hydrogen. And as we are using this process through the renewable energy system, which is main supplier for producing this electricity, for producing this hydrogen and oxygen gas, so we call say green hydrogen. And we can process using just simply water, as we know, but this is not an efficient way of producing the hydrogen. So instead of using, can anyone mute?
Yes, sir. Yes, sir.
right. So if this water is used with the salt water, it's more conductivity, it's carry more conductivity, so it's much efficient. If we use other electrolysis, so it will be more efficient. So actually in electrolysis process, is the process total called electrolyzer. So an electrolyzer contains cathode and anode and a membrane. And the entire system contains pump, vent, a storage tank, a power supply separator, and other components. So based on the membranes, what are the elements we're using, we can define that 3 or 4 types of electrolyzer are available. One is alkaline, and that is photon exchange membranes and solid oxide, and another new anion exchange membranes. So alkaline is commercially available, it's mature. Photon exchange membranes, this is good for renewable energy system, because if alkaline electrolyzer has an issue, or if because of the intermittent power supply of the renewable energy system, in the alkaline electrolyzer, it cannot produce always the hydrogen, but in photon exchange membranes, it has some advantage. It can produce the hydrogen during the intermittent power generation, and as well as it has a startup time is very less, but main problem is very expensive. This is low cost, but this is very expensive because as an electrolyzer, it uses gold, platinum, so it's very expensive. And there's another new technique, electrolyzer has came into the market, anion exchange membranes, that use the low cost from alkaline concept, and the efficiency or the others from the photon exchange membranes, but this is more cheaper with reliable hydrogen production. So after the production of the hydrogen, we need to store. Generally, we store in a compress and liquid. If we want to compress the hydrogen, if we don't compress the hydrogen, it means that the hydrogen tank needs to be much bigger. So not to doing this one, basically we need to compress the hydrogen around 790 atmospheric pressure, and to do this on around 13% of the total energy content is it's wastage. And another way of storing the hydrogen is most popular is the liquefied, where the hydrogen is liquid under the minus 253 degrees Celsius, but the efficiency is much less, only 40%. So that's why in majority case, the pressurized or compressed is better, as it consumes only 13% of the total energy. So there are other methods of hydrogen storage system. There is a method for storing the hydrogen in the ground, and there are also method of solid hydrogen. So if we look at the production, storage, and utilization, so we can see that hydrogen is basically can be produced from natural gas through steam reforming, another method, coal and oil through the gasification, and solar energy, wind and hydro energy through the electrolysis, and other methods, fission, biomass. And after producing the energy, we can store in a different way, but these are most 2 common methods that use. And then this hydrogen is ready to use. It can be used for transportation application, or a stationary, domestic, electric, or heat generation, locally stored energy, and balancing of renewable power generation sector or other sector. So how hydrogen is used? Basically, to use the hydrogen, we need a fuel cell. Fuel cell is a device that takes hydrogen and oxygen and use those to create the electricity. In the fuel cell, there is a catalyst, this basically platinum, and electrolyte. So how fuel cell work? When the hydrogen are sent to the anode, and another oxygen is sent to the cathode. In the anode, the hydrogen is stay in a neutral form. It consists of proton and electron. So catalyst is usually platinum. What the catalyst does, that it take away the electron and it gives the positive proton only. So it separate the electron from the proton, and then this proton can transfer through the electrolyte, but electrolyte will not allow when it is in neutral form. So the proton can transfer through the through the electrolyte, but electron cannot. They provide the separation. So once the proton goes to the cathode side, there are a lot of electrons. We can see here. We are sending the hydrogen from here, and then here the catalyst is separating electron from hydrogen, and hydrogen is bypassing to the electrolyte, and then it's coming here and it's mixed up with the oxygen. But it cannot mix with the oxygen because this is not a neutral hydrogen atom. So this is the only proton. So to mix up, the electron need to travel through the way, and once it come into the form of water and it's go away. So in this way, basically the fuel cell work. And this because of this action, there is produce a heat. So this heat, the water is hot. So basically, what the fuel cell is making electricity and giving hot water. So we can use the heat and electricity both. So we can get from the fuel cell heat and electricity. So there are many types of fuel cells, and fuel cells are classified basically what types of electrolyte they employ, and this electrolyte determine the kind of electrochemical reaction inside them, the kind of catalyst required, what is the temperature range, fuel required, and other factor. Most popular fuel cell is proton exchange membrane fuel cell. This is getting much more attention to the research, and the alkaline fuel cell is the matured fuel cell, and the others fuel cell is also used to produce the electricity. And this is the characteristics of the fuel cell, that the energy conversion rate in alkyl is 45 to 60%, whereas the PEM fuel cell has 40%, and the other have the similar. And for working temperature, is the PEM is only 50 to 100 degrees Celsius. Alkaline need around 60 to 120. And there are others, Fisher, you can see here. So what is the advantage of fuel cell? The fuel cell and hydrogen almost are same. The advantage, because in the fuel cell there is no conversion process, so efficiency with respect to combustion engine is high and is pollution free. It can be used, alternative use of the fossil fuel is environmental friendly. It's very simple, reliable and noiseless. Reliable power supply can be found from the fuel cell as long as you are providing the hydrogen and oxygen. And it can be stuck in a module form to match any power requirement. The main drawback is that in the efficiency, it's much less efficiency in each step. When we generate the renewable energy, if it goes to the electrolyzer, it reduces the efficiency to 70%, and then from the electrolysis process, if it is compressed, because hydrogen needs compress. So if we compress, it reduces the 10%, around 10% efficiency, and then to transport and filling is take another 10%. After that, if we use in the fuel cell, basically is more 20% is less, so around 30 to 35%. And after that, if we use in any electric motor or other things, so it basically the efficiency of the fuel cell is still less. So researcher is trying to combine the electrolysis and compressor together so that the efficiency is improved. And others, new materials they try to discover so that the efficiency can be improved. At the same time, the cost of the fuel cell can be reduced. If we compare the cost with the battery, so in the Tesla Model 3, to fully charge the battery is take only $10 to $12, and it goes around 500 kilometers. So price per kilometer 2 to 2.4 cent. And in the case of fuel cell, Toyota Mirai that you use, to fully charge it is take around $85, and it goes range is 480 kilometers, and the price is quite high still. So that's why you will find a lot of electric vehicle are available in the market, but not the fuel cell. But as the research is going on, so it's expecting that the price of the fuel cell vehicle will reduce. And if we see the energy density, actually hydrogen energy density is much high as compared to the battery, lithium-ion battery. So there is a possibility that in the future the fuel cell will take over the battery, or it will be competitor. In terms of power production cost, if we have a look, the fuel cell power production cost around 103 to 151, which is cheaper as compared to the gas peaking. Gas peaking, as I mentioned before, the gas peaking is generally used when high demand is to meet the peak demand. So it's basically backup generator, and backup generator is used 99% of the time. The backup generator are not used. So in this case, the fuel cell is a good competitor, and solar PV at the least, and wind power generation at the most cheaper. So with the more advanced technology, solar and wind, it will be further less. And if we add the fuel cell, in the meantime, the cost will be less effective. So what are the application of fuel cell? The fuel cell have been used in industry like glass, steel, aluminum, smelter, chemical industry, and mineral processing, heavy transportation, bus, trucking, train, and airplane, because to reduce the size of the transportation system, the fuel cell is used in a bigger, where basically big energy system is needed. So fuel cell is good as compared to the battery. So in heavy transportation sector, fuel cell is taking place. And the hydrogen in residential power and heating system, a small residential storage, hot water heating and cooling residential system. And the hydrogen can be prevent the effect of intermittent power generation from renewable energy sources. And the main theme of the using of fuel cell is that it's provide reliable power supply. So telecommunication, mining, remote area, and where the sensitive equipment are stay. So we need a reliable power supply. So in that places we can use the fuel cell. So in terms of producing the hydrogen from solar system, there are many processes: thermal, electrical, photoelectrolysis, and biophotoelectrolysis, and this come through the basically produce hydrogen. And from the hydrogen, we take this only consider fuel cell, but there are other methods to produce the electricity, gas turbine, and other mechanical energy, thermal energy they can produce from the hydrogen. But we only focus on this one because we only want to focus on the renewable energy sector. So where we can get a reliable power supply from the renewable energy system. And this is the solar hydro energy production system where power generate, and this is the control unit that control how much of when the electrolyzer should turning on and off. So once the photovoltaic power generation, generate power, and then based on the excess or what is the power generation condition, if there is excess power generation condition, it sent to the electrolyzer. Electrolyzer split the water and then it produces the hydrogen, so it's stored in a tank, and from the tank is supplied to the fuel cell. And in the fuel cell, what basically the hydrogen and air is taken as an input, and it's sent the water. This is of course hot water. So they do some process and then they send back to the electrolyzer. Electrolyzer is split again, so it's recycled. And from the fuel cell, it produces the electricity that can meet the power supply, power demand of the network. So there are a lot of research already have been in commercialized. So they use the PV and PV wind micro hydro wind generation with the electrolyzer to produce the electricity. And majority case, you can see the alkaline electrolyzer has been used, and there are some photon exchange membranes have been used, and there are some sort of batteries also integrated in a hybrid mode to produce the hydrogen and to get the reliable power supply. And in the fuel cell have been used majority case, you can see the PEM for photon exchange membranes have been used, and in some cases alkaline have been also used. So there are some ongoing projects in China, Australia, and other places in the world. There are many. I have the list. There are just only few where we can actually contribute in the research. The chemical engineers are working to improve the inside of the fuel cell and electrolyzer by trying different sort of materials, and we can place some of the strategic government support are needed for subsidization, because it's still high cost to build a fuel cell and to produce the hydrogen. So advanced materials need to explore, and intelligent system for control and integration is needed. Where of course we can, those who are experts in control optimization and others stuff, they can intelligently control the fuel cell. These are the little bit of my reference. Thank you all. If you have any question, you are most welcome.
Thank you, sir. Participants, you can ask your queries.
आवाज कुठे गेला आवाजच नाही.
So yeah, basically there are a lot of lists in which area there have been project. So if you're interested, let me know. All right. I can see there are some comment.
Sir, there's a question in the chat box. Shall I read it out, sir?
Yes, please.
The question is from Sagayaraj, sir. Hydrogen tank is explosive. Hence, how to safeguard it when using for electric vehicles?
Yeah, so there are basically issue with the hydrogen tank, especially leakage before, but now with the advance of technology and materials, the problem has been solved. We can say, if not fully, but of course it's now more secure, and this is one of the expensive to store the hydrogen, because hydrogen need to be in a compress, so it means that the tank should be good enough. So it's basically a cost effect is expensive. So your question is how to safeguard it when using actually the lot of materials has came and it's now more safer than the before. Is your course are you clear, or do you need further explanation? Let me know.
Yes, sir. The other question is from Shanti ma'am. Any idea on electrolysis from seawater?
Yes, of course. I mean any water. Any water is fine, but the problem is that when you will use the seawater, it has some chemicals, so it may cause sometimes some pollution. Some other gas can be produced from the seawater because this is the salt. So in the salt, there are other chemicals, so it reacts with them, and when it is split, so it may produce some other gas. So that may not good, but of course we can use the seawater, and there is some project that's ongoing that's using the seawater.
Yes, sir. The next question is from Alex, sir. What is the efficiency of hydrogen fuel cell comparing conventional batteries?
Yes, that's a good question. Actually, the overall efficiency of a fuel cell around 35 to 40%, whereas the battery has efficiency around 90%. So that's why the majority cases you can see the electric vehicle, and Tesla basically hate the fuel cell because this is the much less efficiency, and that's why the battery is the electric vehicle, are a lot of electric vehicle in the market, but as